In this example, we will find solutions to the system of equations y equals 1 minus x squared and y equals x squared minus 1. Remember that if we graph these two functions, then the points of intersection are the solutions to the system of equations. Since at the intersection points, the y value is the same whether we're on the blue curve or the red curve, algebraically we have that the red y equals the blue y, which gives us the equation 1 minus x squared equals x squared minus 1. And now here we have a quadratic equation which we can solve for the x value of the solution to the system. To solve for x, we could get 0 on one side and use the quadratic formula, or we can isolate x squared on one side by adding x squared plus 1 to both sides, giving us 1 minus x squared plus 1 equals x squared minus 1 plus x squared plus 1, which on the right reduces to 2x squared because negative 1 plus 1 is 0, and on the left reduces to 2 because negative x squared plus x squared equals 0 as well. And we're left with the equation 2 equals 2x squared. And dividing by 2 gives us that x squared equals 1, which means that x is either negative 1 or positive 1. Now, we can use the x values of the points of intersection, 1 and negative 1, to find the y values of those points. For x equals negative 1, the blue equation gives us that y equals negative 1 squared minus 1. But negative 1 squared is just 1, which when we subtract 1 gives us 0. So we have that a solution to the system of equations is the point negative 1, 0. And for x equals 1, the y value is 1 squared minus 1, which again is 1 minus 1, or 0, so we get the solution 1, 0. Here, once we got the x value, we found both of our solutions using the blue equation. It's worth pointing out that we can use either equation because solutions are solutions to both equations. If we had plugged the values x equals 1 and negative 1 into our red equation, we would have gotten 0 in both as well. It's also worth pointing out that the graphs were not used to find these solutions. We only used the graph to visualize what the solutions meant. And we could have found these solutions completely algebraically without the graph at all.